Hi, this is John Linneball from John Linneball Tutoring, and this is Breaking Math, Part 5, Shredded and Burned. Sharing shredders. Saul has decided to clean out the documents cluttering his law office and asks his secretary, Francesca, to help him. Francesca brings her personal shredder from home to help Saul finish the job. Saul's office shredder can shred an entire case of copy paper, 5,000 sheets, in 5 hours. When Francesca brings her home shredder, it takes Saul and Francesca 8 hours to shred exactly 2 cases of paper. Assume all papers are printed on standard letter size copy paper and that any downtime for cooling the shredder motors is included in the overall rate. How fast does Francesca's shredder work in pages per hour? This is a work equals rate times time problem, which is the same as a distance equals rate times time problem, just with work instead of travel. Saul has 2 cases of paper, which is 2 times 5,000 pages equals 10,000 pages. We know that Saul's shredder can destroy 5,000 pages in 5 hours, so Saul's shredder would take 2 times 5 hours to shred 10,000 pages, because 2 times 5,000 is 10,000. So Saul's shredder shreds 10,000 sheets over 10 hours, which is a rate of 1,000 sheets per hour. Say that 5 times fast. Saul's shredder shreds 10,000 sheets. Anyway, let's move on. Similarly, we see that it takes 8 hours for Francesca and Saul, using their respective shredders, to shred the same 10,000 pages. So the combined rate is 10,000 pages over 8 hours, which is 1,250 pages per hour, or 1,250 pages per hour, whichever you want to call it. And we can see these formulas for speed equals distance over time. You can just put work where you see speed to get this equation here. Let's move on. So, Saul's shredder has a rate of 1,000 sheets per hour. Combined rate of both shredders, Saul's and Francesca's, is 10,000 pages over 8 hours, or 1,250 pages per hour. We can represent the relationship between Francesca's rate with Saul's rate and the combined rate as follows. F, that's Francesca's, times 8 hours plus S, that's Saul, times 8 hours equals 10,000 pages. So we can factor out the F and the S using the distributive property. So we get F plus S times 8 hours equals 10,000 pages. Therefore, F plus S is going to be equal to 10,000 pages over 8 hours, which is 1,250 pages per hour. So, since we already know S is equal to 1,000 pages per hour, F plus S has to be equal to F, Francesca's rate, plus 1,000 pages per hour equals 1,250 pages per hour. So that's pretty easy math. You just subtract 1,000 pages per hour from each side, and voila, you get F equals 250 pages per hour. You're done. Yay! Okay, so let's take another look at this. The equation without numbers would be something like this. In general, you could write it as R sub 1 plus R sub 2 for, rate 1, rate 2, times T. The time is equal to RC. That'd be the combined rate times T. Makes sense. You combine these together here. So these rates, you combine them, you get this. You multiply both sides by the time. If you want to use specific ones like F and S for Francesca and Saul, and C for combined, you can do that too. So you get F plus S times T equals CT. So if you know your algebra at all, you can say, hey, wait a minute, I've got a T on both sides. Why don't I divide both sides by T to get rid of that T? And that's what we do. So we end up with R1 plus R2 equals RC, or F plus S equals C. Using the rates, we can use Saul's rate of 1,000 pages per hour, and then you can also use the combined rate on the other side. So then you get F plus 1,000 pages per hour equals 1,250 pages per hour. And again, we easily see that F is equal to 250 pages per hour. So we use Saul's rate and the combined rate. Didn't put that there. Oh well, hopefully you understand that. If you don't, hey, you can message me and I will explain it to you if you can't actually figure this out. But I think it's pretty straightforward. Okay. If we know if we know two of the three rates, is what I'm trying to say there, then we can use this formula to find the third. We know that 10,000 pages is equal to one job. That's the job they're trying to do here. We also know that it takes Saul's shredder 10 hours per job, and that both shredders together take about 8 hours. So we know Saul's rate is 1/10 of a job per hour, and the total rate is 1/8 of a job per hour. So we can make a little table. We have the time for Saul. We know it's 10 hours because that's given in the problem. The time for Francesca we don't know, so we're going to represent that with F. And the combined time is 8 hours because it's given in the problem. So the rate for Saul is just going to be one job over 10 hours, again, because it's given in the problem. Francesca, we don't know, but it's going to be one job over F hours, however many it would take her to do that with her home shredder. And so the combined time is given in the problem. It's 8 hours. The combined rate is going to be one job over 8 hours. Now, since we know that the 8 hours comes from when these two are combined, they're both working as hard as they can, as fast as they can, that means that 1 over S, that's going to be basically, that's Saul's rate because it's going to be 1 over the number of hours it takes. And then the other one, 1 over F, that's going to be one job over the number of hours it takes Francesca to do the job, is going to be equal to 1 over C, which is 1 over the combined number of hours for Saul and Francesca. So we know from looking at the table that 1 over 10, it's 1 over 10 hours for Saul, plus 1 over F is how many hours it takes Francesca to do it, is going to be equal to 1 over 8 hours. So 1 over F is equal to 1 over 8 minus 1 over 10. So it's 1/8 minus 1/10. You have to convert that. Okay, obviously the lowest common multiple of 8 and 10 is 40. You can just figure it out. Like, well, okay, what do I do? Well, 10 doesn't work, 10 and... Okay, well, let's see. 20, 30, hey, 40, okay. And 8 times 5 equals 40. Another way to do this is you can just break it down. 10 is 2 times 5, and 8 is 2 times 2 times 2, so you'd say, oh, okay, well, I need 2 more 2, so we can just go 2 times 2 times 2 is 8, times 5 is 40. If you don't get that, there are some very, very good materials on finding the lowest common multiple and the greatest common factor that you can find, including on my videos. Anyway, getting back to this. So for 1 over F, that's equal to 1 over 40. So the answer is it's one job in 40 hours. So 10,000 pages over 40 hours is going to be 250 pages per hour. So you're saying, well, wait a minute, that's, I'm confused, John. That's more time than it took them together. I'm like, yes, it is more time than it took them together because Francesca's little home shredder isn't as good as the heavy duty shredder that they have at Saul's office. So it's obviously it would take a lot longer if they just used Francesca's home shredder than using both that and Saul's heavy duty office shredder. So F is equal to 40 over 1, which is equal to 40. Alternately, the question could have been asked as how long would the job take using only Francesca's shredder? And the answer is, of course, 40 hours. So, then we wouldn't have to figure out how many pages that is, but they could ask that. So for more, you can see my video, Rate Problems 5, 6, 17. Yes, I made that on May 6, 2017, and it deals with similar problems. So let's move on.
Privacy sold here.
Privacy sold here. So, you might be looking for privacy because you have a cash business, and there are different calling plans. And Cal Caller wants to practice.
I practice something we call information hygiene
By buying prepaid burner phones. You know, the idea is you don't have to tell anybody who owns the phone. You don't, you can pay for it using cash, which is completely anonymous. The phone's never registered with your name. It's not linked to a credit card or debit card information, which would be linked to your name, etc., etc.
can't be traced, can't be tracked. That'll keep you clean as a whistle. What they don't know can't hurt you.
So, CC Mobile offers two plans that would work. Any CC Mobile burner phone is pre-programmed with one of these two plans and can't be changed. The only way to change it would be to actually contact their customer service and talk to the people, etc., and you would end up giving them your name. Or maybe it's just programmed that way and it can't be changed. I don't know, doesn't matter, it's just a hypothetical. All of the burner phones offer text messages and phone minutes, but no data. These aren't smartphones and they're really cheap quality. That's why, just like in Better Call Saul, you can just twist them and throw them away, crush them up, and don't worry about it. So we're burning those cell minutes. A burner phone, as I said before, is a cell phone that's cheap enough to replace frequently and that can be recharged using cash or equivalent for anonymous calling. You can go buy those little cards that give you the information to charge it, so you just give them a code. Again, if you paid that with cash, then there's no way for them to know who bought that thing and who used those credits to put extra time on the phone. So, you want to look at the cost of the burner phone versus the cost of the minutes and data. Some of these programs will have a phone that costs a little bit and the voice minutes and data are less, and other ones, for the purposes of our problem, have no charge for the actual phone, but if you want to use it, you have to buy minutes, etc., at a higher rate. So, let's look at our plans we have here. We have the Don't Call Us, We'll Call You, Plan A, phones, and those are free with the purchase of $15 in phone texts and voice minutes, but texts cost 10 cents and voice calls cost 20 cents per minute. So by today's standards, that's pretty expensive. Back when Better Call Saul is set, that's not actually that bad. But anyway, at least I think. I don't know. That was like 2003, 2004, 2005. I don't really know very much. But anyway, this is what I set the problem to. So the other plan is called Talk is Cheap, Plan B, and these phones cost $20 to activate, and then $20 extra for each month for unlimited text and voice phone. So what I mean here is you have to pay a one-time fee of $20 just to activate the phone, and then if you actually want to use the phone, you have to give them $20 each month for the privilege of using the phone, basically for phone service. So the activation cost does not include the minutes or texts for the next month, or for the first month, I should say. So you have to pay for a month's service as well as the $20 activation fee to have a working phone, to walk out of the CC Mobile store with a working phone. All right, let's move on. Burning those cell minutes. Since you have to pay only $15 for the Talk is Cheap plan, that is Plan A, and the phone is free, that seems like the cheapest way to go, right? Well, not necessarily. Since the TIC, the Talk is Cheap, costs 10 cents per text and phone calls cost 20 cents per minute, you could actually spend more on the TIC, the Plan A, rather than the Don't Call Us, We'll Call You, Plan B. So let's assume that Cal Caller, remember him, makes only voice calls and no texts. How many minutes would Cal have to use to make Plan B cheaper in the first month? How about in following months? So we have two problems to do here. So we're going to set up the phone minutes problem. For the first month, Cal would have to spend 20 cents times M, or $15, whichever is more for Plan A, or he'd have to spend $20 for activation plus $20 per month for actual phone service, that is text and voice, for Plan B. So the $15 in Plan A covers $15 divided by 20 cents per minute, which is going to be 75 minutes. You can just work that out on your calculator. Plan B costs $40 for the first month. Remember the activation fee. So for it to be cheaper to use for Cal to use this Plan B, Cal would have to use more than the minutes that would cost $40 under Plan A. So Cal would have to use $25 worth of voice minutes. So that would be $25 over 20 minutes, over 20 cents rather per minute, is equal to 125. So the total is 125 minutes plus 75 minutes is equal to 200 minutes. So any time over 200 minutes would make Plan B cheaper. What about the next months? For the next months, Cal would have to spend 20 cents times M, or $15, whichever is more, for Plan A, or $20 per month for unlimited phone service, text, and voice for Plan B. So the $15 in Plan A is 75 minutes. Plan B costs $20 per month after the first month, so it would be cheaper for Cal to use it in this plan if Cal uses more than the minutes that would cost $20 under Plan A. So Cal would have to use $20 worth of voice minutes at $20 over 20 cents per minute, which is 100 voice minutes. So Cal would need really only to use 100 minutes to make Plan B cheaper. Well, I guess technically he'd have to use 101 minutes, or whatever, just slightly over 100 minutes, and then he'd be billed for 101, and then it would be cheaper to use Plan B. Putting texts in the mix. Skinny Pete takes phone orders from his business selling blue candy and sends a confirming text to customers before he delivers the orders. So he sends one text per customer. Plan A, the Don't Call Us, We'll Call You plan, costs Pete 20 cents to make or receive a phone call, which takes a minute or less because he doesn't want to stay on the phone when he's trying to do business. He's busy. And 10 cents to send or receive a text message. Plan B, talk is cheap. After the first month, there is only a flat $20 fee for unlimited calls and texts. Pete has both a Plan A type phone and a Plan B type phone. So, for every delivery order, Pete uses one voice call minute and one text message. How many orders must Pete handle before it's cheaper to use Plan B? We know that Plan A costs 20 cents for a voice minute and 10 cents for a text order. We know that's going to be 30 cents total for every order, since customers make a call and then Pete texts them back to confirm delivery. So the total is 30 cents per order. Since Pete already paid for his Plan B phone, he doesn't have to pay the $20 initiation fee, just the $20 per month. So let's look at the number of orders. Let's call it C. Why do I call it C? Well, because if I use O for order, a capital O looks too much like a zero, so it's easier just for me to keep track of it if I call it C. You can say C is the number of customers. So it's the same price to use Plan B if the number of orders, C, is equal to $0.3 or 30 cents equals $20. So again, it's C times 30 cents equals $20. So if we divide C by $20, then let's try that again. So C is equal to $20 divided by 30 cents. So scratch that other thing I said, just say C is equal to $20 divided by 30 cents. So then we can just take the number of cents to make this easier, especially if you're not allowed to use a calculator, which might happen if you're using the SAT non-calculator section. You get 2,000 over 30. Now we can just take out a 10 here of each one, because 30 is 3 times 10, 2,000 is 200 times 10. So we end up with 200 over 3, which is 66.66666. You can figure that out on your calculator. So basically, to make Plan B cheaper, you would have to have 67 orders, because we don't have fractional orders, just like we don't have fractional people. So fine, as soon as Skinny Pete makes his 67th deal for this yummy blue candy, that means that Plan B is cheaper. So let's move on. Here's some notes on the real world. No, I don't mean the MTV reality show for the 1990s. I mean the real world that we live in. So, as we see in this little meme that I got here, this came from apparently somebody on Reddit, so user/Yosent, and I got this through Bing or whatever, Google. Anyway, no one. The guy in the math problem. Okay, so we see it looks like a Toyota Corolla full of oranges. Yeah, I mean, we all get problems like that. You know, why is this guy filling a passenger car full of oranges? Maybe you don't want to know. But anyway, in this case, you might ask, well, why wouldn't Pete just use the unlimited phone plan? He's probably going to make calls and texts for things other than just work. You know, he might have a personal life. There's probably people he wants to talk to, etc. And 20 cents for calls adds up pretty quickly, along with 10 cents per text. You'd be absolutely right, but word problems don't reflect the real world. They just need to know, do you know how to do the math? And they're trying to give you something to see if you can turn words into mathematics. You know, can you translate English to math and then math back to English? So let's move on. So another thing you might see when you're doing algebra problems and, you know, you deal with some kind of crazy problems where you're like, nobody would ever do that in their world, are things like where you're mixing things in the industrial, scientific, technical, or even just the commercial world. So let's say you're going to your friendly auto mechanic, Manny Mechanic. So Manny says, hey, I would like to make a gallon of antifreeze solution containing 30% antifreeze and 70% water. But what I have right now, I have gallons and gallons of 90% antifreeze and 10% water solution. And it doesn't matter how much water I need to use. I can just use tap water. And, you know, I have water, you know, connected just like everybody else in this town. So the solution, well, Manny's just going to mix it roughly half and half and call it good. Manny wouldn't really say, you know, I need this particular strength of antifreeze. Most likely he'd say, in these weather conditions, in this location, if you mix it half and half, that's pretty good. So, you know, that's fine. You know, 90%, you mix that half and half, you're going to get 45%. That's probably as far as he would go. He probably wouldn't even know. He'd say, yeah, you know what, everybody mixes it half and half. That works pretty well. So, he's not going to use algebra to solve this problem. And yes, Walter White here, Walter definitely would use algebra because he's a scientist and a chemist and he would do that. And it looks like, look, what was that guy's name? Rick had an unfortunate accident here when somebody used a metal-edged squeegee to short-circuit the connectors on the battery, which overheated it, and oops. I'm sure that Walter here is just running to go get help, so they'll put this out. Ha ha ha. Anyway, the takeaway here is, yes, Walt probably would use algebra, but don't annoy him when he's working on your car. Ha ha ha. Or don't get where he can open the hood to your car and get a metal squeegee after it. All right. Thanks. Have a nice day. Did you find this video useful? Please like it and subscribe to my channel. Neither action costs you anything. You'll be alerted about my new videos. Why? It's really simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. While many people are watching these videos, I don't have 4,000 hours of watch time in the last year. I do, however, have 1,000 subscribers, actually more than 1,000 subscribers at this time. So thank you so much to everyone who actually helped me out by subscribing. Ad money will help me make more of these videos. And speaking of ad money, if you've seen an ad during this video or my other videos, please know that I did not get any of the ad money, and I won't until I have the subscribers and view time that YouTube demands. For the same reasons, you are not only welcome but encouraged to share links to this video, put it in playlists, etc. I gladly read and respond to constructive criticism or suggestions for new videos that are also constructive. I reserve the right to delete comments such as troll posts or spam for obvious reasons. Nobody likes trollers and spam. You can hire me for tutoring. We can do it online through Zoom or some other similar internet platform, or we can meet in person. I live in the San Francisco Bay Area, so if you're around there, it's pretty easy for me to come see you. I do travel to other cities sometimes, so you can always contact me and ask me if I'm going to be in your city, and that's another way that I might be able to meet with you in person. Thanks for watching, and my contact information follows. You can contact me on Facebook, facebook.com/Linneball Tutoring, all one word. Instagram, it's instagram.com/John.Linneball.tutoring. And the phone number, this is my cell phone, 415-623-4251. You can always call me or leave a text message. Email, you can always email me at john@johnlinneball.com. Website, you can reach me at johnlinneball.com or johnlinneballtutoring.com. They take you to the same website. And you can also find me at testpreparation.locals.com and at lbry.tv at John Linneball Tutoring. That's a nifty little site, lbry.tv. My actual postal mail address is John Linneball Tutoring at 1859 Powell Street, number 109, San Francisco, California, 94133.